Hello my dear students, welcome back to Learn Physics. In today's topic, we are continuing with our kinematics portion, graphs. So already we learned in the previous two classes about the graph in uniform motion, uniformly accelerated motion. First it is retardation and then acceleration. Those graphs we learned. And here in one thing you should remember is the graph which is showing like, see at the same time different positions. Suppose if we are drawing a displacement time graph, if the graph is like this, or if the graph is representing in like this, okay, same time at different positions, okay, these and all are not possible for graph in the in motion. When we are considering the one dimensional, two dimensional, anything, this kind of motions are not allowed. So velocity time graph also, this shape, if it is coming, that is at the same time different positions. For one particle, it can't reach to the same position at different same time. Different positions is not it won't be there at all. The same way, see velocity time graph in circular motion, circular manner. This also won't be there. Okay, so this and all, this also you should please keep that in mind. Okay, now we will do some numerical relating to this. Introductory exercises. Two particles A and B are moving along x-axis. Their coordinate versus time graphs are as shown below. Okay, here position is given here in meter, time in second it is given, and here it is 4, this is 8, and two graphs are here, one starting from 4 and this is B, and another starting from 10, this is A. Here it is 30 and here it is 10. Okay, clear? So find the time when the particles start their journey and the x coordinate at that time. So we find the time when the particles start their journey. So particles started their journey. A started at 10. It's not a straight line, okay, it will be I'll represent like this. It's like this, okay. So here A is starting its time starting at 10 meter and B is starting at 0 meters. Okay, so this is x and this is time. When A started its motion, so x coordinate for A, your coordinates will be 10, 0, and here it is given, this is 0, 10 we will write. Usually this one we will be taking as x-axis, right? So if I am taking here as x coordinate, here it is 4, 0. So when we started our observation, A is at position 10 meter and B is at 0 meter. But for B, we started our observation at 4 seconds. Okay, so here the question is, find the time when the particles start their journey. Time. So for A started their journey at 0 second and B started their journey at 4 second. And x coordinate at that time. So when they started their journey, A has 10 meters and B has 0 meters. Find their velocities of the two particles. Velocity, how can we find out the velocity? From displacement time graph, we can find out the velocity as, yes, here you can take one small triangle over here and find out the distance, the distance divided by time. That is, x-axis is this one and time is y-axis. So here dy by dx for A, if I am considering for A, this is for A, y coordinate is, here it is 30, 20 divided by and then time is 8, 20 by 8 meter per second for A, and for B when we are considering, see here we can take like this distance is 30, distance traveled divided by time is 4. 30 by 4 meter per second. This will be the velocity. So from displacement time graph, how can we find out the velocity? By taking the slope of the graph. Slope of displacement time graph will give you velocity. Next is when and where the two particles strike with each other. So two particles are striking at 8 seconds when both are at 30 meter away. Okay, so next question is the velocity of a car as a function of time is shown in figure. Second one, velocity is here and here it is time. This is velocity 0, 10, 20 meter per second. Here it is 2, 4, 6, 8. This is in seconds. So here at 4 it is given 10 seconds, like that it is shown. Find the distance travelled by the car in 8 seconds and its acceleration. From velocity in how much seconds? 8 seconds. So here we need to add 8 seconds. What will be the distance travelled and acceleration? We need to find out. From velocity time graph, how can we find out displacement? Distance travel can be found out with the help of from the slow area under the graph will give you area under the velocity time graph will give you distance covered, and acceleration will be slope of velocity time graph at 8 seconds. So till here it is. So we can consider this triangle, area under that triangle, that is OAB. So half BH, half into base is 8, h is 20. So here we will get it as 80 meter. Since it is under uniform motion, distance and displacement will be same only. It will be 80 meters. Acceleration, how can we find out? The y-axis dy by dx or tan theta, anyone you can consider. Dy by dx will be equal to 20 divided by 8. So here 4 5, 2 by 5, 2.5 meter per second square. This is how we will be finding out acceleration. Next is figure shows the graph of a velocity versus time for a particle going along x-axis. So first we will draw the graph. So this is the graph which is given over here. From the graph, find the acceleration. Acceleration we need to find out. Distance travelled in 0 to 10 seconds and displacement in 0 to 10 seconds. Okay, displacement. Here acceleration we need to find out. Velocity time graph. You tell me how we will find out the acceleration. Acceleration equals distance travelled divided, velocity divided by time. The slope of the graph. Any one slope you can find out from here. See here, this is one if I am considering. Here 4 to 8. So acceleration will be equal to 4 to 8 means it is 4 divided by time is 5. So 0.8 meter per second square. This will be the acceleration. Then displacement from 0 to 10 seconds. Displacement, how we can find out? Or distance covered only it is asked. Since it is under uniform acceleration, we know that it will be the distance and displacement will be same. V is equal to, here how can you find out displacement? S is equal to area under the graph. Area under the graph will be, here you can consider it as a trapezium, half into sum of the parallel sides. What is that? 2 plus this is 8 into distance between, horizontal distance between the parallel side, that is 10. So here you will get it as 50. Since it is the uniform acceleration, displacement and distance will be equal to area under the graph, that is equal to 50 meter here. Okay, displacement also will be equal to 50 meter. Then next question. Figure shows the graph of the x coordinate of a particle. X coordinate of a particle along with x as a function of time. Okay, here it is time in given in seconds, and here x in meter, here it is 50, and here it is 100 meter. Then here 2.5, 7.5, 10, and here 15. So here it's increasing, then till 7.5 it is constant, and then increasing up to 100, then it is decreasing to 15. Okay, now find the average velocity during 0 to 10 second. Average velocity 0 to 10 second. Displacement time graph. How we will find out the average velocity? Average velocity equals distance traveled divided by time. What is that? 0 to 10 second. Final position is 100. Initial position is 0 divided by 10. So the answer is 10 meter per second. Average velocity is 10 meter per second. Instantaneous velocity at 2, 5, 8, 12 second. In instantaneous velocity 2, 5, 8, 12 at 2 seconds. How we will be finding out the instantaneous velocity over there? Instantaneous velocity will be displacement y-axis divided by x-axis. So here displacement it is under uniform velocity till 2.5 seconds. So till 2.5 what is the velocity? For 2 second velocity will be equal to 50 divided by 2.5. So here it is 500 divided by 25, 20 meter per second. Next is 5. At 5 seconds, see 2.5 to 7.5 second it was at rest. So at 5 second velocity will be equal to 0. At 8 second means it will be coming between 7.5 and 10. So it is under uniform velocity. Since it is under uniform motion, so here you can find out the slope of the graph. Here slope will be 50 to 100, 50 for 8 seconds. Now I'll write it over here. For 8 seconds slope, how can we find out? Y-axis divided by x-axis. Velocity will be equal to 50, 100 minus 50 is 50 divided by time as 7.5. So you will be getting it as it's 7.5 only, right? 7.5 to 10. It's 7.5 to 10. So 10 minus 7.5 is 2.5. Here you will again get it as 20 meter per second. Then at 12 second means from 10 to 15 it is decreasing, deceleration. So velocity is decreasing with respect to time. How can you find out? You can find out this slope, that is 5 seconds, and here it is 100. 100 divided by 5, that is 20, minus 20 meter per second you will be getting. Okay, since velocity position is decreasing with respect to time, so it is minus 20 meter per second. Clear? So these are some of the questions, and here one more question is given. I'll give that as a homework for you. Please try to solve it. From the velocity time plot shown in figure, find the distance traveled by the particle during first 40 seconds. Also find the average velocity during this period. So this is the graph. Velocity time plot is given. Distance traveled by the particle for the first 40 seconds. Distance traveled from velocity time graph. How can you find out the distance traveled? Area under the velocity time graph will be giving you the distance traveled, and average velocity during this period also you should find out. Okay, try to solve it. In next class I'll explain this also. Next class, and along with that we will be discussing relative motion. Velocity of A with respect to B, B with respect to A, and acceleration of A with respect to B. That and all we will be discussing in the next class. So I hope today's video is useful for you. Please, for those who didn't watch the video the previous days, that also please watch it. Then you will be getting a clear idea about the topic, I guess. So, and if you like the channel, please don't forget to subscribe, like and share. Thank you for watching. Bye.